All right. Good afternoon, everybody. Thanks for joining me. We are going to be talking today about machine learning operations or applying DevOps to data science. You might have also heard it referred to as MLOps. And this is the idea of taking what we know about DevOps and what we've learned over the last many years deploying software and applying some of those best practices and techniques to the machine learning operations. And basically nailing down some of the processes to get our data science projects off the ground. So I know that most people in the audience are developers. Who here would say that they're a developer or programmer? Yep, great. That's most of the room, presumably. So you're probably familiar with how programming works. And if you start with a problem in programming, you know that you have to solve that problem by creating an algorithm, some kind of set of if statements and where loops and while loops and all sorts of stuff like that, such that you can give it input, or we'll call it data, to that algorithm, and it will come out with an answer on the other end. Now, machine learning kind of works the opposite way. We don't really know what the algorithm is. To calculate some mathematical result, I know how to write the algorithm to do that. But to identify whether there's a cat in a picture, I can't even think about what the algorithm would be. So machine learning is good for solving those kinds of problems, and the way it works is by swapping those two things around. We provide a whole lot of sample data with the correct answers, and then the computer itself is the one that learns how that data matches the answers. So it creates an algorithm or a model, which is what we call it in machine learning terms, that describes that data in terms of an algorithm. Now, the great thing about these models is you can really just feed them in where we would have written that algorithm before, such that your application can run the input or the data through that model and come out with predictions at the other end. Now, it's important to realize, of course, that these are just predictions. They're not answers. They're predictions based on the model that's been gleaned, and they will have differing levels of success. Now, part of the machine learning and part of the machine learning and data science process is coming up with better and better models to give us better and better predictions. To do that, we need to improve the data, we might want to improve our algorithms, and we want to keep these things up to date, very much the same way as we do with software, adding new features and fixing bugs and things like that. Now, Tailwind Traders, who you may have heard of a few times at this event, is a hardware supply company. They provide hardware devices like, hammers and wrenches and all of that kind of hardware to the general public. And they have an online store. Now, one of the features on their online store uses machine learning. It uses an AI technique for image search. So if we jump over to the Tailwind Traders website, we can see that there's a smart shopping button here on the top of the website. So the idea is, rather than typing in wrench, or that you want to actually search for a wrench, you upload a photo of what it is you're searching for. It will run it through our machine learning model and come out with an answer. So here it's identified that what I uploaded was a picture of a wrench, therefore it's given me all of the search results for wrenches, and we only have one in our catalog, so there's only one returned. But this machine learning algorithm, that model, is not actually wonderfully accurate. So here's a picture of a claw hammer, and I'm going to upload that, and it comes back thinking that that's a wrench. And if we dug into the details there, we'd say that it was actually fairly confident that that was a wrench. So we obviously need to make changes to our model and start improving those changes. Now, just like with software development, we might just go in and change some of the details of our algorithm. We've probably worked that out ahead of time and done a whole lot of experimentation, but here I'm just going to make this small change. The details of the change don't really matter. And just like with software development, I'm going to commit and push this change. So we're going to update the number of epochs, in other words, the number of times we're going to train or run through our training process, and we're going to commit that and we're going to push it. Now, we'll come back to what actually happens a little bit later, but this is very similar to what we would see in our software development, where a commit runs through a pipeline which ultimately pushes our code back out to production. So we'll get there soon, but let's jump back and have a look at some of the other details of what the machine learning process looks like in general. So when you're doing machine learning, from scratch especially, there are really three kind of phases. There's a data preparation and exploration kind of phase where you look at the data that you have and you tune it. You select features and maybe you do some transformations. So in our case, we have a whole bunch of images. Those images aren't really things that you can perform maths on directly, but what you can do is maybe turn each of the pixels into a different level of grayscale, so how dark it is or so on. Maybe you resize all the images so they're the same size. Basically, you're doing a whole lot of data preparation. In terms of other tabular data, maybe you want to change addresses into GPS coordinates or longitude, latitude coordinates. So there's a whole lot of data preparation that happens first. There's some building and training efforts that have to happen. So this is the algorithm that we have, and we need to tune that algorithm with hyperparameters and change maybe with the algorithm that we're using to generate our model. And then once we have a model, we evaluate the success of that model and see how well it performed. And then we go back to the drawing board. We do these loops just like we would do with software development. And maybe that means we have to go back and retune our data, or maybe it just means we change the algorithms that we're working with. Now, this kind of loop can take some time. There's tools like Azure AutoML, which can speed up this process, especially for the build and train step, by trying a lot of different algorithms at the same time and tuning the hyperparameters for us. But ultimately, this is the work that needs to be done. Once we have a model that's ready to deploy, though, then it gets a bit tricky. And traditionally, we have the same kind of problems as we have with software development, where quite often that model will be produced just on a data scientist machine or some shared hardware, and it will be packaged up ideally, and then thrown over the wall to somebody to deploy it to our application in production. Now we see the same thing in software development, and this is what DevOps is trying to help with. The work that goes on for actually doing that code, what we want to avoid is for all of that to just happen on somebody's machine, and the deployment phase, we want to avoid that happening by passing around emails or USB keys and things like that. Now with DevOps in software development, you're probably familiar, we have this big process that's put together where we go from planning the work that we're going to do to developing and testing our work to releasing it ideally to other environments before production where we can run some more tests, and then releasing out to production. And then of course, once it's in production, we want to monitor and we want to learn from what's happening in production as well. So it's not just a case of throwing things over the wall. Ideally, DevOps is about being able to have this cycle and to run through this cycle quite quickly, but also safely. So we do our plan, a test, release, and monitoring in production as fast as possible in order to deliver value. And ultimately, that is what DevOps is all about. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And the key word here is that we're delivering value to our end users. If we think about software, so the web application that we're showing you with Tailwind Traders, if we introduced a new feature, we need to make sure that that feature is actually valuable. If it's not, then we're just guessing. We're just doing busy work, and we're releasing things that the public is not going to actually get value from. But the same thing happens with our data science projects. The ultimate aim of any software or any technology project is to provide value to the customer or to the company itself. If we can produce a predictive model that performs better than our previous predictive model, then that is absolutely providing value. So there's no reason to change the definition of DevOps. It doesn't exclude data science and machine learning. In fact, it absolutely includes it. If we have these features in our application that provide value, improving those features is obviously improving the value. So now we're trying to work out how to do continuous delivery of this value. And work with the people, have a process in place, and what products we want to use to actually get that value out into production on a continuous basis. So in terms of products, Microsoft has an Azure machine learning service that's part of Azure. And now this is a collection of different services that enable you to kind of deliver your ML ops or your machine learning operations. We have a lot of tools like automated machine learning and the visual interface for actually creating machine learning projects without actually writing any code yourself. We have a way of storing Jupyter notebooks and other files that you might need as part of your process. And then there's a whole lot of stuff to manage the actual process of training actually training your models and doing that work itself. And I want to focus on those because this is really the core of what machine learning operations is all about. So let's just zoom into these. We have these assets, data sets, experiments, models, endpoints, and we also have a number of resources that are available to us, like Azure Compute and data stores for storing that data. So let's just go through these one by one. Data sets is the concept of registered known data sets. In other words, if you have several petabytes of data, you don't want each developer or each data scientist to have a copy of that data on their own machine, or ideally, even worse, just a subset of that data on their machine. If they're doing that training, we want to make sure that everybody is working with that same data set. There are some additional features to data sets that I'll share towards the end to do with data drift and retraining efforts as well. Experiments are basically all of our training runs. So when you run a training run to get a model out of an experiment, a model produced, you're essentially running an experiment, and Azure Machine Learning Service will track these experiments for you. The models themselves, of course, are registered version models, so you can produce a whole lot of models and then just register and version the ones that you care about, the ones that you actually want to deploy. And then endpoints actually consists of two parts. There's real-time endpoints, in other words, models that you have deployed. So this is what we're using in our Tailwind Traders website. We're using a model that we've deployed to an Azure container instance. And there's also pipeline endpoints. Now, these are the endpoints that you can hit to kick off a pipeline. So this is really Azure Machine Learning pipelines, and the way you access that is via that pipeline endpoint. So these are our workflows for all of the things that we need to do to actually train our models. And then the last two, the bits that we can manage, we have managed compute, and this is really important in machine learning terms. It's not, if I was to train those models on my laptop that I have right here, it would take a very long time. I have managed compute in my Azure Machine Learning service that has a bunch of GPUs and a ton of RAM. That means that I can very quickly train these models where I wouldn't be able to on my own hardware. And because it's managed compute, it means I don't have to manage those resources myself. And then data stores is basically our connections to any other kinds of data that we want. These are actually used and referenced by data sets, but the data stores concept allows me to connect to Azure Storage or upload some files or connect to a large database or an Azure SQL instance or something along those lines as well. So these are all the different things we're doing. Because we're talking about machine learning operations or DevOps for data science, we're going to start with pipelines. So we're going to create an Azure Machine Learning pipeline which defines our training workflow. In our case, it's just those three steps: our data preparation step, our build and train step, and then our model registration step is what we're doing at the end. Now, if you are across a number of different Azure services, you might have noticed that that the word pipeline is a little bit overloaded. We actually have two of these services. There's the Azure Machine Learning pipeline, but there's also Azure Pipelines, which is part of Azure DevOps. Now, these are two different products and they do two different things, but they actually integrate really well together. Azure Machine Learning Pipelines is generally for machine learning workflows, so the process of actually doing our training. Azure Pipelines is much more generic. It's to do with, it's generally focused on building applications and deploying those applications, continuous integration, continuous deployment. They communicate a number of different ways. There's the Azure DevOps extension for Azure Machine Learning, and that allows you to interact in a much more familiar way if you're familiar with Azure Pipelines. You can use the Azure command line interface extension, so AZ extension, called Azure CLI ML. And then if you're using Python, which is pretty popular in machine learning terms, there's also a Azure ML SDK for communicating with Azure Machine Learning. And all of those ways are different ways of communicating with Azure Machine Learning pipelines, whether you're doing it from Azure Pipelines or whether you're doing it from another CI/CD tool. So Azure Machine Learning pipelines itself, let's just drill into why you would want to use this. Essentially, it provides workflows with a number of steps that can use data sources and data sets and compute targets, so other concepts in our Azure Machine Learning workspace. And it's really about training our models. You can run you can do runs in an unattended fashion, which means you can kick them off and then come back later. Now this is important because Azure machine learning training runs can quite often take a long time, especially if you're using low priority compute to save some money, and we'll talk a little bit more about that in a sec. It means that even if your training run takes a few days, you can kick it off and come back in a couple of days. And this is something that'll be difficult to do with Azure DevOps and Azure pipelines. It's also reusable. So we're defining a number of different steps, but you can reuse those steps as well. Potentially, maybe your data preparation step takes a very long time, but you don't need to do that every time. You can just reuse the results of previous steps and only run the steps that you need to run to do your retraining. And then finally, it also allows you to track and version a whole bunch of ML concepts. Things like experiments can be tracked and run. The models that are produced can be tracked and versioned and run. And you can get traceability from the pipeline all the way through to the workflow, to the experiment that actually ran, the model that was produced, and then the deployment of that model as well, in a way that makes sense from a machine learning perspective. Azure Pipelines, by contrast, is really about orchestration, especially for continuous integration and continuous delivery. So it's really good at doing things like when code changes, kicking off a new run. It allows you to put in tasks and gates and other processes for code quality, which is important, especially in a machine learning process, because we do need to ensure the quality of the code that we're writing. It's good for integrating with other services. So if you have some parts of an application that are built maybe somewhere else with Jenkins, or if you're deploying to an on-premises location or communicating with IoT Hub, it's really good at integrating with those other services, which is something that the machine learning pipelines doesn't really do. And importantly, you can trigger runs on code and non-code events. So if your code changes, you can absolutely trigger a new run. Things like a Docker Hub, a new image being registered in Docker Hub, or if a Jenkins build completes, you can kick off a Azure Pipelines run then as well. So it's really a broader orchestration tool. So when we're creating this pipeline, we're going to start with Azure Machine Learning Pipelines itself. And what we're really going to be doing is using the rest of the concepts in here, except for the deployment. We'll come back to the deployment a little bit later. So we're using data sets and data stores, we're running experiments, we're producing models, and we're using managed compute to actually do the training itself. So let's have a look at what that pipeline might look like. So let's jump over to our Azure Machine Learning workspace, and we can see that there's this is exactly what we saw in the screenshot. We have a Jupyter notebook, and if you're a data scientist, you're likely to be familiar with Jupyter. It's essentially a way of writing code and coming out with responses in a cell-based mechanism. So we have a cell here which does all my input statements. We're using a certain version of Azure SDK. We're connecting to our workspace. We are connecting to our data store, which is what I mentioned we were using for our data sources. We're connecting to our compute target as well. So you can see back in our Azure Machine Learning workspace, we have this compute, which is a standard NC12. I also have compute for my notebook, my Jupyter notebook. So this is what this notebook itself is running on too. But we're connecting to this Seer compute, which is my training machine. And then we're defining our pipeline. So this is where we're going to define what our Azure Machine Learning pipeline looks like. So again, we're connecting to our data. We're defining an environment for our data preparation and our training steps. They will actually use the same environment. And then we're defining our data process step. Ultimately, this is just calling a parse.py file. So this is a Python script that we have to do our parsing. We're feeding in where the data comes from and where it's going to go to. We're defining our training step. We're defining our model registration step. And again, these are just using scripts. And then at the end, we are publishing this pipeline. We're defining it as these 3 steps. We're publishing it, and then we're running an experiment for that published pipeline. We also have a few tools for Jupyter as well, which allow us to get a nice visualization of what's happened here. So we can see we've provided that data source. We've got a data preparation step, our model step, and our model registration. And we can drill in and see that experiment in Azure Machine Learning Workspace as well, if we want to actually look at some of the details and find the logs and all sorts of stuff like that. We've already got that open, so let's just leave that here. So we did this all in Jupyter, but you might have noticed when I actually made that change before, I did it in Visual Studio Code. And this comes back to some of the ways that we're communicating and collaborating as a team. Now we'll come back to that in a little bit, but first I just want to summarize what our pipeline looks like. We've done our data preparation, we've done our training step, and we've done our model registration step. We're using our data sets and we're using Azure Compute. Sorry, yes, we're using Azure Machine Learning Compute. So then when I was talking about we actually did this in Visual Studio Code, this is about collaboration. And this is one of the big things that comes to us from DevOps. Some of the DevOps good practices that we want to look at in this session are source control, continuous integration, continuous delivery. So in terms of source control, we want to make sure that we're able to share our code between members of our team. And this might be between different data scientists, or it might be between the data scientists and the software engineers that are producing the application that uses it. We want to version all of the code and the comments. Jupyter Notebooks, in our case, which is what we're using in our case, it actually saves as part of that file the output. So you'll notice when I was showing you that, I didn't actually run anything. I was just showing you the output from the last run. The Jupyter file itself contains the output as well, which is great for sharing information, but it's not so great if multiple people are using it. And we need to deal with merges in Git and things like that. So we want to keep the code and the comments only. We basically want to extract that code into a way that can be automated and that can be shared in a nice way. We want all that code, everything that we need to do for the training, plus every part of that pipeline. So we had those script files, those Python script files to do the training and the data prep, but we also have that pipeline in a file as well. So that's our Azure Machine Learning pipeline. We also want any of the infrastructure that we need, so the Azure Compute and all of those dependencies, so the Python SDK dependencies and things like that. That should also be part of our code base, and maybe possibly a subset of the data. Now, remember, we're talking about potentially terabytes of data here, or even petabytes of data for our training. We probably don't want to put that in Git. So everything should be in source control, except for your training data. And that should be a known shared data source. So in Azure Machine Learning Services, you're probably looking at a data set there, which is a known location for data, which you can just mount as part of your training exercise, meaning you don't have to keep copies of this for every single data scientist in your team. But everything should be in source control to enable collaboration. Let's talk about continuous integration. Now, I mentioned that Azure DevOps was really good at triggering these events on code change. So whenever I change my pipeline, like I did just a minute ago by changing the number of epochs, whenever I change that pipeline, it should trigger an Azure DevOps run. We should, in that case, refresh and re-execute our Azure Machine Learning pipeline because we've changed the way that we want to do our training. We can add in tasks if we want to for code quality, for linting, for unit testing, all of the stuff that we would normally do with our software development. We want to ensure that quality for our code as well. And we can even do things like pull request processes. In other words, we maybe don't want to kick off a very expensive training run every time somebody makes a change, but only when somebody makes a change to our master branch. So maybe we can have a pull request process, do some code quality, linting, and unit testing with those pull requests, but only when we merge back into master, we want to refresh and re-execute our Azure Machine Learning pipeline. If you want to get started with Azure DevOps, by the way, dev.azure.com is really the place to go. The important part here, though, is that code quality matters even in data science. So it's very easy to say, well, I'm just going to do everything with a Jupyter notebook, and I might just execute those tasks one by one. On an environment that I have. The work's actually going to happen in Azure Machine Learning Service, but we're still not doing any unit testing or linting or code quality, which we want to do as part of a good DevOps process. So I'm just going to pause there before we go to the to the deployment part, and we'll look at this build that we have running. So let's just jump over to our Azure Machine Learning build, to our, Azure DevOps here, our Azure pipeline. I'm just going to refresh this, and we should be able to see that there's my change where we updated our epochs for accuracy. What's actually happened is we've done a whole bunch of, we've run a whole bunch of steps. The important one though is recreate and submit pipeline. Now this basically ran through and it called our scripts that I was showing you before to resubmit our pipeline and then do another experiment based on that run. We can see this here. This is our setup pipeline py. This is the execution, this is the file which is the equivalent of what was in Jupyter Notebooks. We've added a few things like being able to pass in some arguments like where our data source is, what compute we're using, and then some versioning so we can have that traceability all the way through. But it's ultimately doing the same thing, connecting to our workspace, connecting to our data and our compute target, and then defining our pipeline. So our data process step, our training step, and our registration step. And then we're kicking off a new run. So it's exactly the same as what we saw in Jupyter Notebooks. Our pipelines YAML, which is the way that we define our build definition in Azure DevOps, is going to trigger on any change to our master branch, which is what we saw. It's going to run this on Ubuntu, and then it's going to do all of those tasks that we saw that were executed. When we recreate and submit our pipeline, we're just running this script, setup pipeline.py, passing in some details. So that will recreate the pipeline and execute it. So what we've got here is basically a call out to Azure pipelines. To Azure Machine Learning service to queue up a new pipeline. So now we have this model. So let's just jump back to our Azure Machine Learning workspace, and we can see that we have version 1.60.1. If we go to our experiments, we should be able to see that our SEER experiment, which is the one that we're running, it was last executed there we go. It was last created, very recently, 9:24 a.m., so about 20 minutes ago when I made that change, and it's completed. We can see a lot of statistics about how well it went, our duration over the number of runs, and if we drill into that run as well, we can see some statistics and some details about how well that went. We did our data preparation step, our model training step. Again, we can drill into those steps individually and see how our accuracy improved all the way up to about 75%. So we get a lot of detail. We obviously also get our logs and our outputs and so on. And if we drill into models, we can see that the model was created as well. So we can have a look at that model. And even if we wanted to, we can download the model file itself if we wanted to deploy it somewhere else. So we've created this model. We've basically run through our pipeline. We've done our data preparation, our training, and our model registration as part of that pipeline. But now we want to deploy it. Now we want to actually push that out so we can use it in our application. So I could, of course, add to my Azure Machine Learning pipeline. I could add one more step over here that does that deployment. And in fact, we do want to use Azure Machine Learning to do that deployment. It knows how to take that model file, turn it into a Docker container, and deploy it to Azure Container Instances or AKS. But I don't want to do it in this pipeline. And the main reason why is that third point when I was talking about with the good DevOps practices, continuous delivery. So we want to, again, trigger a continuous delivery job on model registration instead. So however long that takes, we want to wait until a new model is registered. Then we want to be able to deploy to test and staging environments and run tests on those environments to make sure it actually works. We can run some integration tests and load tests and things like that to make sure it's actually performing the way we want. The key here is that we want control. So if I added to that Azure Machine Learning pipeline and just deployed whenever I created a new model, I don't get the opportunity to run tests on my test and in staging environments. I don't get the opportunity to control my rollout to those environments. maybe do some A/B testing, maybe enable the new model for only a subset of people using feature flags. Azure DevOps, using that for the continuous delivery, gives me the opportunity to ensure quality when I actually deliver that model to production. The important point here is that we're controlling that model rollout exactly the same way we do with our software. So rather than just deploying any new model to production, we want to control that rollout. So let's have a look at what that looks like. If we go over to our Azure Pipelines release, the first thing you can see in artifacts is that we're actually grabbing an artifact from Azure Machine Learning Service. So we're looking for a new model called SIA, and we're getting the latest version, and we're actually doing a continuous deployment. So whenever there is a new model registered, we're kicking off this process. Now, I actually only have one stage here. We're getting some versioned files, which is the bit that they're actually going to fix, and I won't need to do this anymore. And then we're using the extension to do an Azure Machine Learning Model deployment to Azure Container Instances. So I'm grabbing that model, the artifact that I've got, and I'm deploying it to Azure Container Instances using the extension that I've got. And you should be able to see, if we go back to our workspace, actually, sorry, let's just go to the view releases. Because we should be able to see there's actually a deployment happening right now. It's in progress. So that model that's been created has kicked off an Azure Pipelines release, and it's doing this model deployment. We can see this in the Azure Machine Learning workspace as well. If we look at endpoints and have a look at this ACI deployment here, we should be able to see that it's transitioning right now. So it's in the process of deploying to Azure Container Instances. We can see some other properties about it, like where the source, where it came from, where the code repository that's ultimately produced the model, which we're ultimately deploying, is all the way through, and even some details about how big this Azure Container instance is. So while we wait for that to deploy, let's look at our complete pipeline. We have our data preparation, training, and model registration, and they are all part of our Azure Machine Learning Service pipeline. When that model is registered, we also kick off an Azure DevOps release pipeline. Right now, we're just deploying to Azure Container Instances. But as part of our controlled rollout, maybe we want to look at some statistics on how well that is performing in a production-like environment. Maybe we want to run some load tests. Maybe we want to do some evaluation. And then perhaps we want to deploy to AKS. So if you're familiar with Azure DevOps, you'd probably be familiar with the same kinds of, we've just deployed that, the same kinds of processes that you would use for software development. So maybe we have another environment here that does deploy to AKS, and we do the same tasks, except instead of deploying to Azure Container Instances, maybe we deploy to Azure Kubernetes Service. We could even do some things like add some deployment gates, exactly the same way as we would do with software developments, just this time we're deploying our model itself. Now, that's completed, it looks like. So if we refresh this in Azure Machine Learning Workspace, we can see that it's up and healthy. So let's just test whether that's actually improved things. So let's upload our wrench just to make sure that that's still working. It's going to run that through our newly deployed model in Azure Container Instances and come out with, right, a hammer. So it's actually done worse. So this is where we would want this pipeline to make sure that we're actually deploying something that is successful into production. Let's see how it's doing with the other one, core hammer. So we've uploaded that hammer. Okay, it's done a little bit better there, but obviously there's still some work that needs to happen. So even though the training succeeded and we ended up with a model that looked like it did a decent job, having this kind of rollout control in Azure pipelines is really important. We probably wouldn't want this to go to production directly. So this extra step that we've got here of evaluation and then deploying to AKS is really important. Now, one thing we haven't talked about here is the idea of retraining. So it's important with our machine learning projects that we have a retraining strategy. So with our software, we don't want to let our software just sit and have the same features that it did 10 years ago. It's even more important with machine learned models as well, especially as new data comes in. So maybe on a schedule, or maybe when there's some kind of data change threshold, we want to be able to retrain this pipeline. So run through that Azure Machine Learning pipeline with new data, and then obviously kick off our deployments as well. Imagine if we started getting new products in, or a new category of products in, but we didn't retrain our pipeline to identify those kinds of products. Obviously, our machine learning model that is used to do that prediction of what you've uploaded is going to start getting quite stale. So you need this retraining strategy. Azure Machine Learning service actually has the idea of a training data set that you can attach to your Azure Machine Learning pipeline. What that means is that you can, based on what's in that training data set, retrain, and you'll end up with a model deployed to production. But then whenever somebody makes a request to that model, like we have, we can add that change to an inference data set. Azure Machine Learning Service can actually compare those two data sets, and based on whatever statistics that you care about, it can look for this data drift. In other words, is the data that we're getting through our production system significantly different than the data that we use to train our model? And based on that, once it hits a certain threshold, we can re-kick off another pipeline. That's one scenario where we might want to do our retraining. The other scenario is if our training pipeline itself changes. So we've decided that we're going to make a change to our code, which is what we did in our example. We changed some of the details of our training pipeline, and so on that, when we did that, we recreated our Azure Machine Learning pipeline, which basically retrained our data based on our new algorithm and new parameters, and then kicked off another deployment. So these two scenarios enable us to handle both retraining and also a complete pipeline refresh as well. Now, this was just an example of a way you can apply this. I was using Azure Machine Learning Service and deploying to Docker containers with Azure Container Instances or Azure Kubernetes Service, but you may want to be embedding your model in software, especially if you have, for example, a mobile application. Maybe you want that model to be directly inside the software as well. The same concepts apply. Maybe you're going the other way around and you're not actually producing a model out the other end. You're just calling one of the APIs that we have, like Azure Cognitive Services. They have a fantastic API, which means all of these great concepts that we've gone through, you can absolutely use them with cognitive services as well. Control your rollouts and make changes according to new data and retraining strategies. The key here, though, is if you're using Azure Pipelines as your base, it's able to orchestrate anything. So here we're using Azure Machine Learning Services, but you don't actually have to if that's not the way you're doing your data science project. So just in summary before we wrap up, here are some of the key points that I want you to go away with. Number one, all code and infrastructure should be in source control, exactly the same as we would do with our software development. For data, we should use known shared data sources so we have consistent training based on consistent data sets. And you can use data sets and data sources in Azure Machine Learning Service for that as well. Azure Machine Learning Pipelines and Azure Pipelines work really well together in a number of different ways. You need to make sure that you have retraining strategies as well so that you're not just sitting there on stale models that are running in production. And then finally, for the actual deployment, you need to make sure that you're using the DevOps good practices for delivery. Things like A/B testing, rollouts, test and staging environments, and all of those good things that we do with our software development as well. If you want to learn more about Azure Machine Learning Services, there will be some links here to the docs. If you want to do some MS Learn for learning about AI and things like that. All of the session resources for this session will be here. And all of the code that I showed you, if you want to run it yourself, will be there. And for the entire event, go here. Upcoming session alerts as well. Blah, blah, blah. All right. Thank you.